YouTube too. Okay. How many students do you have? Okay, that's pretty good. Would you meet them every week or every 2 weeks or? That's awesome. Yeah, oh yeah, totally. Oh, is that from like one of those like Maury shows or Jerry Springer? That's great. I guess I don't know. I don't think that Maury or Jerry Springer are still a thing. I guess it's more like Dr. Phil now. Yeah. Yeah. That's great. Okay, so we got a few people here, so I think we can get started. So what we're gonna do today is just gonna carry on. We're gonna be on Unit 2 now, which of course is derivatives or differentiation. So I took a look at your exit slips yesterday. I don't think I got an exit slip from everyone who was online. So if you forgot to fill out an exit slip yesterday, I'll just ask that you fill out 2 exit slips today, just so we get those numbers to balance out. It's important for me that one view gets like one little tick mark on my exit slip counter, so that when I submit the number of students I'm reaching, that number is as accurate as possible. So if it goes down one day, like if one day is like lower than it actually was supposed to be, then maybe the next day can be one higher. So then when you take the average, then you guys are all math students. I don't have to explain that to you. Okay, so anyway, yeah, I was taking a look at the exit slips, and people seem fairly indifferent. Some people told me that they actually have been making like a study guide since day 1. It seems like you did that for a few units with Mr. McIntosh. So I think it's a good idea that we keep doing it. One student, I forget who it was. Anyways, one student mentioned that they would be interested in a like a shareable document, like a Google Doc. I think that's a great idea. My only hesitation with that is that writing out math symbols in Google Docs is challenging, but it is possible. It's just a little bit challenging. Yeah, I think there is. I just don't know how robust it is. But you might have more experience with it than I. I haven't really. Oh, then. Yeah. All right. Yeah. So you got your limits, got your integrals, then you're good. As long as it can do a fraction too, then yeah. Okay. So maybe why don't I set that up? I'll put it on our website, and I guess what you could do is you could have 2 options. Because I know that some people would prefer just to have their own study guide, and that's perfectly fine, and I don't want to get in the way of that. So what we'll do is you'll have 2 options for a study guide. You can either partake in this shared document, yeah. So then I'll make a link, and I'll kind of, maybe I can be in charge of like the structure of it, and then as we go throughout this week and next week, we can kind of define our roles a little more clearly. But for now, it'll kind of just be a free for all. So I'll have that up hopefully by the end of the class, because we are going to do some free response questions. So that should give me a little bit of time to sort of make that happen. So yeah, we'll do that. But if you want to do your own personal study guide, that's fine too. This is not mandatory, but I do think that it would be really fun to kind of have something collaborative, and Google Docs is awesome too, because you can actually see each other's work and that sort of thing. So I think that could be really fun. And also maybe if you misplaced your notes for a unit or something like that, or maybe you didn't quite understand a topic, then this could be another great place just to say, okay, well, looks like these students understood it. So you can kind of rely on your peers a little bit to help you out. So we'll do that. I think it's a great idea. So that's what we're going to do today. We're going to start off with a little study guide. I'm going to give you just the topics or the list of topics for Unit 2. And after that, I'll assign some free response questions. I still don't know how to view your answers. I can see who has submitted their solution, but I haven't figured out how to view your solution and mark you. So I actually don't know if that's supposed to be up to me, or if there's some kind of elf in the computer server who's actually marking these things for you. I don't know how that works. So, okay, yeah, I'll talk to Yost. I think he's online right now, actually. Oh no, he's not. But yeah, I'll send him a message. Yeah, that's a great idea. Yeah, because teachers should collaborate too. All right, so yeah, let's jump into it. Okay, so let's start off with Unit 2. So Unit 2 is on differentiation. So Unit 2 is differentiation. So taking derivatives, that kind of fun stuff. So it's kind of a shorter unit. I think Unit 1 had something 16 subtopics. Unit 2 I think has 10, so it's a little bit shorter. Okay, so the first one is defining rate of change in an instant. So basically, what's an instantaneous rate of change? Instant, and I'll write that, aka instantaneous rate of change. Okay, so how do you define that? And of course, we would do that with a limit. So next up we have derivative notation. Okay, and that would be using things like f prime of x versus dy by dx, or y prime or y prime. So what do all these things different mean? So talking about derivative notation. Next up is estimating derivatives. So that would be if you're given a graph or a table of values, would you be able to take a look at that and sort of be yeah, I think I know what the derivative would be. Or I should say derivative at a point. So not the derivative as a function. That you would actually need the full function, but estimating the derivative at a point, you can usually do that just by looking at a table of values, that kind of thing. So connecting differentiability and continuity. So how are continuity and differentiability related? Okay, so how are those two things related? And also when do derivatives not exist, right? They don't always exist, right? Just like a limit. A limit doesn't always exist. When that limit, because the derivative is a limit, right? So when that limit doesn't exist, then that derivative doesn't exist. Okay, we got the power rule. which is probably the most fundamental of all the rules in calculus, the power rule. So I don't believe you are asked to prove the power rule. The power rule is actually quite straightforward to prove using limits in algebra. Like if you just look at the actual definition of a derivative, then the power rule comes out of it quite easily. But I don't think you need to worry about like deriving the power rule. Just understand it, how it works, that sort of thing. Okay, so now we've got some more derivative rules. Oh, and by the way, this is like 2.1, this is 2.2, 2.3, 2.4, 2.5, 2.6. I should be clear about the numbering system here. I don't know if you can see my cat, but she's right in front of my computer screen. Bye-bye. Okay, so 2.6 is, yeah, just more rules. So derivative rules. And the rules that are part of 2.6 are like how do you take the derivative of a constant, the derivative of a sum, what else? Sum, difference, yeah, kind of the same thing. Well, that's the power rule. The power rule is in that one. And a constant multiple. And constant multiple. Okay. And then 2.7, here, let's go over here now. 2.7 is some of the trig ones, so trig functions. So sine of x, cos of x, and oh, and then I guess we also have and others that are not trig functions. So e to the x, and let's make that look a little nicer, e to the x and ln of x. Okay. And then next up we've got the product rule, 2.8, right? The product rule, that's a fun one. And 2.9 is the quotient rule. To be honest, I never really liked the quotient rule. I've always found that like you're better off turning your second, like you're better off using the chain rule and the product rule combined. So like instead of having like if you want to find the derivative of this, like x plus 1 over x plus 2 or something like that, I've always found it's better to use the product rule on this times x plus 2 inverse, right? And then use the product rule with the chain rule. It just makes more sense to me. I've never really been able to memorize the quotient rule without having to, really think about what it is. Like if you ask me what the quotient rule right now is, I probably stumble a little bit, to be perfectly honest with you. And then 2.10, the last one is just the rest of the trig functions. So the rest of trig functions. Pardon me? What about the chain rule? Yeah, I don't see the chain rule on here. I wonder if maybe the chain rule is in chapter 3. You would think that the chain rule would be in here. Oh yeah? Yeah. Okay, so yeah, we would find tan of x, cotan of x, what else? Secant and cosecant. So secant is that, and cosecant is that. Okay, so just kind of the oddball trig functions. And a lot of this, that's just kind of memorization, right? You just have to memorize those derivatives. And that's supposed to be an S over here, cosecant. No, those aren't in Unit 2. Those are, like, we did those, that was something that we did together. I think that was, what, Unit 7? Right? because then you actually have to define what those are. It is kind of a pretty deep topic. So yeah, those are the units for Unit 2. So yeah, like I said before, if you want to kind of have your own study guide, then you can make kind of your own thing. Maybe you already have been making a study guide all year, and you can just kind of add to it or kind of refer to it. So that's sort of the core for Unit 2. I'm gonna go into AP Classroom now. I'm gonna assign some FRQs. Okay, AP Classroom. Here we go. And what was the website that you guys had to use? Like AP Student? Okay. Oh yeah, AP Students. Okay, give me one sec here. All right. Okay, so let me add do your progress check, assign, go into Unit 2, and we're going to do free response questions part A, and this is skill 1E, which I can assume would be 2.1. Anyway, I'll assign that now. And unlock assessment now. Let students see the results. No time limit. All 40 students, even though there's not 40 of us. And okay, so you should have it now. You should have access to the free response questions. I wonder if maybe at some point this week we can try doing a live test session. I don't know if that makes this process any different. I don't know if it makes it like more closely related to the actual final exam, but we might want to experiment with it just in case. Yeah, exactly. So it is Unit 2 Progress Check FRQ Part A. I'll just paste that into the Discord here. I'll also paste it into YouTube. I realize that I might not be completely fair to all the YouTubers who are watching the stream. I tend to sort of have most of my attention on Discord. So there you are on YouTube. So that's what you're looking for. Unit 2 Progress Check FRQ Part A. And let's see what these questions look like. Let's see if we can try to attack some of them. I'm going to give you a little bit of time, and I'll try to catch up with you. Where did it go? There you are. So I'm just trying to open it. FRQ. Part A. Okay, there we go. Let's preview it. Oh, a graphing calculator is required for this question. Okay, that's fun. Okay, so yeah, it looks like we're going to be using some of the product rule here. We'll be using a few different rules. Yeah, we'll be using the product rule and the power rule. It kind of looks like we're going to be using the chain rule as well. So I guess the chain rule is in here. Why don't we just write 2 point Mr. Bennett. Talk about the chain rule here. Because this question you totally need the chain rule. Unless I'm completely mistaken, can you do this without the chain rule? Part A. Yeah, but look at g of x. Right? Like if you, right, because you've got, so n of x is equal to f of x times g of x. Like I wonder, maybe it's possible to do this without the chain rule, but I don't know exactly how. And then f of x is, well, who knows what f of x is? It's that kind of funny looking function. We could figure out what it is. Looks like it might be some kind of piecewise defined function, or maybe some kind of absolute value function. I don't know, but in any case, it's f of x, and g of x is this guy right here. It's x squared plus 5x plus 5x to the power of a third. And even if you were to use the chain rule here, or sorry, even if you were just to use the product rule, you would have to end up finding the derivative of this, right? You'd have to find d by dx. Oh no? Ah, okay. Okay, so I understand now. So you could do this with your graphing calculator. I see. Yeah. Okay. Perfect. So yeah, use your graphing calculator to do that. Perfect. So I'll let you kind of work on that. In the meantime, I'm gonna. Okay, we're doing the free response question, the Unit 2 progress check. Yeah, you were here for that, I think. You asked about it. Oh yeah, I was just looking at this. Yeah, I thought we would have to use the chain rule here. So I made an amendment, but I guess we don't have to talk about the chain rule in this. So I mean, if you want to add a chapter here about the chain rule, then you can. But I guess we don't have to use the chain rule. Although you should know your calculator is using the chain rule. Okay. Perfect. Where are you getting 6? Okay. Mm-hmm. Yeah. Oh, I'm just seeing a note in the Discord here. Temporarily unavailable. Temporarily unavailable. That's too bad. But it seems to be working for other students. If you can't do it right now, that's fine. I guess what I can do is I'll copy and paste the question into the Discord. So here we go. Oh, you can say whatever you want. Mm-hmm. That's yeah, that's what I would do. Yeah, no, I think it's got to be one or the other. Okay. Okay. I'll ask some of the other teachers what to expect, because they might have some information that I don't have. But yeah. Just trying to see if I can punch this into my calculator without any troubles. X squared plus 5x. Oh, shoot. There's no undo button on a TI-84, eh? Yeah, I hit clear on this equation that I've been punching in for the past 2. No, I'm on like the y equals portion. Brutal. Okay, let's try that again. Mm-hmm. Yeah, the slope there would be at -1, and the slope is -2. Mm-hmm. But that's the slope of f, right? Not f of x times g of x. Like, you have to be careful, like the slope of the slope of n prime, or like the slope of n at -1 is not just equal to the slope of f of x at -1 times the slope of g at -1, right? Like, that's, if only life were that simple, right? You can't just find those. Oops, that's supposed to be -1. Yes. We can certainly say that, like, around the -1 area, f of x kind of approximately is the same thing as -2x plus 4, right? Yeah, I would just put it all in one thing. I'm just struggling to find the right buttons on these calculators because I'm not very good at using the. Why just write the product? Like this is what I'm punching in. I'm writing out like y1 equals negative 2 times x plus 4 times the whole thing. Oh, you can, eh? Okay. That would have saved me a little bit of time. So how do you take a derivative of another function here? Because I've got this, and I found the nth derivative function, and it's giving me this. So it wants me to, and it gave me like a block here, right? So I told it I want it to, I put x in there, but okay, but how do you do y1 though? That's my question. Is I can see y in the calculator, but oh. Aha! Awesome. You guys are good at this. Right. No, not quite. Now, sorry for asking all the noob calculator questions, but I'm still on that first one. I'd really like to know how to do this. So I've got everything punched in. Like I've got y, and if when I hit enter, it just goes down to y3, and it's saying tell me what y3 is. And if I go back over here and I hit solve, then it doesn't do anything. What do I? Mm-hmm. I just want the value at a single point. Oh, I see. And how do you go back? Oh, okay. So quit. Oh, I see. Okay, and then you do the math thing. Okay, I get it. Right. Okay. Okay, so we're gonna do that with it. Yeah, that is a funny question. I think that, from what I understand, the final exam is supposed to not be calculator heavy. So hopefully that will work in our advantage in this case. So by the way, for part A, I'm probably like 10 steps behind you, but I got 5.556. Yeah. Okay. I would assume it's a pretty similar process for part B. It looks like, so now you've got the function g. You're going to use g again, right? So g is going to be the same thing. G of x is still, what is it, like that x squared plus 5x to the third power. But now f of x, if you look at f of x, around the point x equals 4, it's kind of more close to, what would that be, 1/3 of x? 1/3 of x plus 2/3, I guess? Plus 2/3, right? So just use that. Five-thirds, thank you, yeah. Yeah. At least one of you is wrong. Actually, at least two of you are wrong. Yeah. So, like it sort of ends. Oops, it ends like over here, right? And then the slope is 1/3, right? So yeah. So basically, we're trying to find what the y-intercept is. So if you kind of extend this, it goes down 1/3 every time, right? So this isn't actually the best drawing. Oops. It's kind of like that. Well, that way we just have the whole function. Like, we would need the function because in, like, this is still relevant. We're not just taking the derivative of f, right? The rest of the function is still relevant to the question because we're doing, what is it going to be? G of x over 5 times f of x. So g of x times 5 times f of x, right? So this 5/3 is still relevant. Absolutely, yeah. You could say that this is equal to 1/5 times f of x times g of x to the -1. Why is g of x not to the negative? Oh, I got that. Yeah, my bad. Oops. This is supposed to be f. That's supposed to be g. Yeah, my bad. Good call. Yeah. So yeah, like what I would do is I'm not gonna try to bother to do the calculator work because it's gonna I'll be here all day. So what I would do is write the function out, which is g of x, which is x squared plus 5x to the third divided by, well, in this case we've got 1/3 of x plus 5/3, but we're multiplying it by 5. So whatever buttons you have to press in your calculator to get that, and then take the derivative of it, right? So d by dx. Mm-hmm. Yeah. That's right. So yeah, when x is between -3 and -1, f prime of x is, what is that, -2? Yeah, -2. So that doesn't change. So yeah, when is h of x prime equal to -2? So you just solve for that equation. So find h of x and its derivative, right? So h of x is, what is it? It's the 7 cos x plus x cubed. 7 cos x plus x cubed. Find the derivative. Be 7 or -7 sine of x plus 3x squared, and set that equal to -2. Right? Solve for x. Yes. Did you remember the 5? Oh well, it's 2:12 already. This day's blowing by. I don't know. I like at 1 o'clock I jumped into the shower, being like, oh, I still have an hour before calculus, and then in the shower I was like, wait, no, 1 o'clock, no. So I had to rush out of my shower. It's crazy. Yeah. Okay. So I'm gonna go because I'd like to prepare a little bit for grade 11. If you have any difficulties with this question, oh, there's only one question today. Oh, that's not too bad. Your exit slip. What should we do for the exit slip today? Yeah, why don't you just give me your, yeah, so the exit slip for today, exit slip is just, yeah, part A, B, and C. And like if you don't have that on you, like if it's just infeasible for you to solve all those three, just fill the exit slip out anyways and just tell me that. It's really important that I have accurate numbers of who's showing up to these streams. So please just fill it in regardless. And if you forgot to yesterday, fill in 2. So yeah. And if you also just want to do like part A, that's fine as well, or part B, or whatever. But yeah, that's what our exit slip is going to be today. So I'll talk to you guys tomorrow. Have a good night. Oh, and I'll post on the website a Google Doc so you can start that collaborative document if you so desire. So take care, guys. Bye bye.